So next item would be funnels. This one is an ordinary funnel. So let's just call this funnels. We have different sizes at the top. Then you have a somewhat funnel without a long tube with it. But anyway, that those are long mounted funnels. This one's an ordinary one, but it comes in different sizes, of course. To differentiate it with your filtering funnel, you usually have the perforations and your Buchner funnel. So I'll be emphasizing this one. Both of these filters actually, but this is intended for smaller particles. But again, these perforations here, even the ceramics here, are backed up with filtering papers. You usually put filtering papers at the top. Of course, not to contaminate the filtering materials. So, and then, depending on what you're using, what you're doing. For example, if you're filtering smaller particles, you can use this one with setup like the filtering flask. Anyway, I'll be showing it next items. So again, this is a filtering funnel, a funnel with bigger perforations wherein it can screen bigger materials, of course, solid materials, and then the liquid will go out from this one, of course, with your filtering papers. But if in case you don't need filtering papers, you can just use it as is. Anyway, this one is more suitable than this one because it may clog the pores of the silica, so it may damage the Buchner funnel. So still, you have to put filtering papers even for this one. Okay, Buchner funnel, and then you have filtering funnel. Next item is a filtering flask. So it kind of look like the Erlenmeyer flask, of course, because it is somewhat straight going to the top. But then you can see this glass here protruding, and you can see that there is a hole. Usually when you can see glasses like this one, this is intended for suctioning. That's why it is called filtering flask, because you usually put filtering materials, filtering tools like this one. You put it here with probably rubbers, so that as you put it here, it will not snuggle, and then this would be out from air, meaning it would be vacuum if ever you'll be suctioning this part here. So this part allows you to suction or get the air from this one so that it would have vacuum inside. So if there already vacuum inside and this one is sealed, then it can filter more. Because the tendency of your filtering process is that it will slow down as more material is filtered. Why? Because of course your solid materials will block the liquid from going through the funnels. Of course, that's the use. So, you may use a suction part here. Some laboratory has vacuum mechanism, wherein they can just plug tubes here with vacuum, and then it will already suck the air inside, thereby making the liquid with solids that you're filtering filter. So, it settled down. Again, that's the use of your filtering setup. You have your filtering flask, and somehow you have your filter funnels. You have your Buchner funnels, or probably your filter funnels. Of course, with your filter papers. And that is usually common with organic chemistry, wherein you have some crystals that is being formed, and organic crystals formed from a chemical reaction. Then, voila, there would be solids from your beakers, and then you pour it in your funnels with filtering papers, and then when you see that the liquid that is dropping is already so small, then maybe you can use the filtering flask for that, meaning suctioning this part. Actually, I tried using suction tube or suction or bulb or aspirators, but again, it is better if you have really a vacuum compressor, of course, with lines, vacuum lines, for it to be suctioned properly, and then you have a liquid that's already filtered. Okay. Next item would be forceps. It resembles like forceps are symbols like the one that is I think it is what we use nipper, I think, for the nails. But anyway, some call this tweezers, or we can call this forceps. wherein it has at the last part it can hold things. Of course, for chemistry or analytical chemistry, it can hold filter papers. For example, if your filter was used for hazardous substances, or probably you don't want to come in contact with substances with respect to your filter paper, which is being wet now because of the filtering process that you have made. So you can just get the probably your paper which is already dried, and you can hold it with this, or anything that you want to hold, smaller pieces of materials you want to hold without using your hands, you use forceps. Sometimes it's most usually used for biological materials. For example, you have dissecting frogs, just like this one. But anyway, we have biochemistry, bio labs here for general chemistry and for analytical chemistry. Maybe you can use this in terms of maybe papers, compounds in contact with any glass tools when we don't have to touch those things. Okay.